Usage of the word orthogonal outside of mathematics. From the roots ortho, straight, and gon, angle, its meaning in mathematics is understandable. Outside of mathematics it has various meanings depending on the context. Debate, orthogonal, not relevant. Statistics, orthogonal, unrelated. Computing, orthogonal, isolated or partitioned. There are other definitions. Most seem to imply a meaning of independence or separation. Does anyone know how it came to mean this?
Because in mathematics orthogonal is synonym of being independent or absolute lack of dependence. Th array are intermediate states from no dependence to complete dependence, aka parallel, which is given by vector product. This URL update I did not want to implicate, but without it my answer is not answering direct question. In Russian primary school the vectors are studied in the 4-7th form, and after that children tell in conversations parallel instead of dependent and orthogonal or perpendicular instead of independent.
If you think about, simplified for convenience, mathematical usage of orthogonal, it is referring to vectors at right angles to each other, so motion in the direction of the first vector produces no corresponding motion in the direction of the second vector. This independence is what motivates the other meanings. An orthogonal line of argument in debate might be interesting in itself, but doesn't advance the main thrust of the debate, for instance. It's just as well that the mathematical use of normal doesn't bleed across like this, because normal people would then be at right angles to reality. Then again, smiley face.
As Wikipedia says about the derived meanings of orthogonal, they all evolved from its earlier use in mathematics. In statistics, the meaning of orthogonal as unrelated, or more precisely uncorrelated, is very directly related to the mathematical definition. Two vectors x and y are called orthogonal if the projection of x in the direction of y, or vice versa, is 0. This is geometrically the same as being at right angles. The statistical meaning comes exactly from this. One can think of random variables as living in a vector space, and correlation between two random variables is 0 precisely when the two vectors are orthogonal/perpendicular. See this post for details. In debate, orthogonal to mean not relevant or unrelated also comes from the above meaning. If issues x and y are orthogonal, then x has no bearing on y. If you think of x and y as vectors, then x has no component in the direction of y. In other words, it is orthogonal in the mathematical sense. In computing, the use of orthogonal for isolated or partitioned, which I don't actually recall encountering, would come from the same meaning. The behavior of one component has no bearing on, is isolated from, other components, so they are orthogonal.
In construction fields, orthogonal is used instead of perpendicular.
If you want to support the channel, please consider liking and subscribing.